Okay, we are Geometry, section 1.3. We're going to be using midpoint and distance formulas. Some of you may have just groaned at the sound of that, but it's all right. It's just a little formula. We have to write it down on a note card so we don't forget it, and life will be okay. So, to begin, the midpoint of a segment is the point that divides the segment into two congruent segments. Remember, congruent means equal. Okay, we've already learned what congruent means. All right, a segment bisector is a point, ray, line segment, or plane that intersects the segment at its midpoint. A midpoint or a segment bisector bisects the segment. Okay, so we have a midpoint or a segment bisector cuts a segment in two equal pieces. That's what bisect means. Cuts into two equal pieces. Okay, I've had a hard time remembering that in the past, so I'm hoping you guys work really hard to remember that a bisector or a midpoint bisects the segment. Bisect means cuts in two equal pieces. All right, first of all, here we have M. M is the midpoint of AB. This little tick mark right here, that's what this is called, is a tick mark. It means that segment AM is congruent to segment MB, or AM is equal to MB. Okay, AM is equal to MB, or the length of AM, segment AM, is congruent to segment MB. Okay, a little reminder, this means lengths, right, the actual measurement, and this means pictures. All right, here we have CD as a line. Erase that. Line CD is a segment bisector of segment AB. It's a segment because I have two endpoints. So line CD, because I have two arrows on the end, is a segment bisector of segment AB. So it's cut into two equal pieces, bisected. Segment AM, right here, is congruent to segment MB, or the measurement of AM is equal to the measurement of MB. Measurement, which is the length, okay, measurement is the lengths, or the pictures. Pictures are congruent, lengths and measurements are equal. All right, first example, in the skateboard design, segment VW, just right here, segment VW bisects segment XY. Okay, so they bisect each other. Let me erase that. At point T, if XT equals 39.9 centimeters, find XY. So if XT equals 39.9 centimeters, I have a tick mark right here. I have the same tick mark right there. That means they're congruent, their lengths are equal. So if we want to know XY, we would do 39.9 plus 39.9, or you can multiply 39.9 times 2. Okay, pretty simple. Example 2, algebra. I love algebra. I hope you guys like it too. Here we have point M is the midpoint. That means it has bisected that segment VW. So find the length of VM. If that's the midpoint, we know that this segment and this segment are congruent. Since we know they're congruent, we can set them equal to each other. We can say 4x minus 1 is equal to 3x plus 3. Okay, if M is the midpoint, that means that segment VM, here, let's do this. Let's erase this. We can say that VM is equal to MW. And then we can substitute. 4x minus 1 is equal to 3x plus 3. And then use some algebra to solve your equation. Add 1 to both sides. I get 4. Subtract 3x from both sides. I get x equals 4, But what's the question asking? Find the length of VM. VM is 4x minus 1. We know that x equals 4. VM equals 15. Very cool. All right, here's a you try. Go ahead and push pause and try this one on your own, and then push play and check your answer. All right, PQ is equal to PM plus MQ. And these tick marks here tell us that PM is equal to MQ. So PQ equals PM plus MQ, but the tick marks say that they're equal. PM is equal to MQ. So I'm going to substitute right here. I'm going to substitute out MQ, plug in PM because they're equal. We know that PM is 1 7/8. PM is 1 7/8. So 1 7/8 and 1 7/8 is 2, 3 6/8. Reduce this. Divide by 2, divide by 2. I get 3 3/4. Okay, number 2, find PQ. Push pause. Whoa, gotta love the fractions in that one. Just so you know my flow, I started here. That doesn't really read very well. Okay, I started here. Then I went up here. So first I said that PQ equals PM plus MQ. Okay, then we know that PM is congruent to MQ, so I set them equal to each other and plugged in the equations. Solved for x. Went back right here, plugged in x. Okay, kept going down this way, and then got my answer. Okay, if the fractions are confusing you, please don't let them. I bet you have a calculator that will help you. Just ask me, and I'll be happy to show you. All right, coordinate plane. You can use the coordinates of the endpoints of a segment to find the coordinates of the midpoint. There's a midpoint formula that you may have used in the past. Please write it down on your note card. You will need it, and I don't want it to confuse you, okay? So the coordinates of the midpoint of a segment are the averages of the x-coordinates and of the y-coordinates of the endpoint. Average means you add two things together and you divide by 2, okay? So we're going to add the x's together and divide by 2. Then we're going to add the y's together and divide by 2. It's the average. And that'll give us the coordinates. Find the midpoint. The endpoints are given. Find the coordinates of the midpoint. So like we said, we're going to add the x's together, divide by 2. Then we're going to add the y's together and divide by 2. So we have 4 plus 1 over 2. Those are the x's. And then 2 plus a negative 3 over 2. The coordinate of the midpoint is 4 plus 1 is 5 over 2. We're just going to keep that at 5 halves. I guess I can simplify it to 2 1/2. Very illegible. 5 over 2, or 2 1/2. It's easier to plot 2 1/2 sometimes. All right, 2 plus a negative 3 is negative 1 over 2. So negative 1 over 2, which is just fine on its own. So these are your answers. They're equal answers, so it doesn't matter which one you use. And let's just check. I have 1, 2 1/2, negative 1/2. Okay, positive 2 1/2, negative 1/2. Midpoint formula. Now this is where it gets harder. If you're given the midpoint and one endpoint, find the coordinates of the endpoint k. Okay, so we're given a midpoint and we need to find an endpoint. So we know that x, let me write in black, we're just going to label it x, the midpoint, if I can write. X, the midpoint, is x1 plus x2 over 2. And then y, the midpoint, is y1 plus y2 over 2. Okay, let's plug in what we know. We know that x, the midpoint, is 2. We know that x1 is 1, and x2 we don't know. So we're going to leave that as x2. Alright, I'm trying to solve for x2. I need to get rid of this right here. The best way to get rid of it is to multiply both sides by it. So I have 4 equals 1 plus x2. x2 equals 3. Cool. Let's try it with the y's. The y midpoint is 1. y1 is 4. We do not know y2, but we can figure it out. So multiply both sides by 2. If you can see what I just drew, gets rid of that. I have 2 equals 4 plus y2. Subtract 4 from both sides. And there I have y2. So the endpoint is 3, negative 2. Let's check the drawing. 1, 2, 3, 1, 2. Perfect. Okay, you try one. Push pause and try it on your own. There we go. We have the midpoint. Okay, we know the endpoint, we know the midpoint, we know one endpoint. We need to find the coordinates of the other endpoint. Okay, try this one on your own. Alright, check out the work. Make sure it makes sense before you move on. Okay, distance formula. The distance formula is a formula for computing the distance between 2 points in a coordinate plane. Granted, in the past, we've had a line that's been horizontal like the horizon or vertical. It's easy to compute those distances. You can just count the squares, right? You can just count the distance. But when you have a vertical, when you have a slope line, the distance between endpoints that are horizontal and vertical, so if we're trying to find this distance, you can't count the squares. You need the distance formula. So we have A and B are points in a coordinate plane. The distance between A and B is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. A great thing for your note card. Can't spell. Awesome. There we go. Let's try one. What's the approximate length of RS with those 2 endpoints? Okay, we're just going to do the distance, the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's plug everything in. We're going to just pick. I'm going to say this is x1, y1, and this is x2, y2. Okay, I could have switched them. It really doesn't matter as long as you are consistent. So we have x2 is 4, x1 is 2, quantity squared, plus y2 is negative 1, minus y1 is 3, squared. 4 minus 2 is 2, 2 squared is 4, okay, plus a minus, 16, square root of 20. Let's check that out. I have about 4.5. Okay, needed a calculator for that one because it was not a perfect square. You try. In example 4, does it matter which ordered pair you choose to substitute for x1, y1, and which ordered pair you choose to substitute for x2, y2? Push pause. Think through your own answer before you listen to mine. Okay, you need to stay consistent. As long as you pick 1 point for x1, y1 and 1 point for x2, y2, your math is going to work out. But you cannot change like x1, y2, x2, y1. Okay, they have to be the same point. Alright, you try again. What's the approximate length of AB with those endpoints? Push pause and calculate it on your own. There we go. Alright, daily homework quiz. 3 pages. Here's page 1, page 2, page 3. Okay, 2 points. Good job.